Assalamualaikum and good morning everybody. So welcome to MRG and also IEEE ComSoc series, talk series for this morning. So it is honor to me to be invited to deliver a talk for this morning. And I think it's already past of 4 minutes from 10. So then I will start my sharing this morning. So thank you everybody for making a time to participate to this talk series. Right, so let me share my screen. I'm IBRAHIM from the Micro Research Group members and also NSCOM to the IEEE Communication Society, Communication and VTS Society. And I think this the topic for this morning, I think is quite interesting, which is the engineer and society bridging the gap through the telecommunication engineering. All right. So why I choose this topic? So initially, I would like to talk more about the advanced communication system, which is about for 5G and 6G. But thinking that we still have some issues related to the unconnected society, and this is why I think it is quite a significant topics to be talked and to be shared to all of you. And I try my best, right, to bring this scenario about the connected and unconnected, and how can we bridge the gap over the telecommunication engineering. Okay, so as you can see, this was a report in 2017, which is they have a World Economic Forum at the Davos in 2017. The special session for the Broadband Commission, right, and the World Economic Forum. So the data at that time, there was in 2016, about 90% of the developing world are still not connected. And if you look into the region, that's also include the Asia and Asia Pacific, which is 2.4 billion people are still offline. And of course, the highest is the Africa, which is 760 million. Even though the Europe, all right, if quite we consider Europe have major developed country, but the numbers of offline at that years also is quite big, which is 181 million. And due to the studies, it shows that especially in the Africa and Asia and Arab states, due to the geolocation or the surface or the geography of that particular areas, that are very tough for them to deploy the telecommunication or the telecommunication infrastructure. Right. So this is, I think, the typical topology, or the typical how do we connect from the backbone to the last mile devices, right? So of course, for the backbone, we need to have the fiber optic connection, but of course, not many countries afford to have this connectivity over the fiber, and due to the geographical surfaces of that regions, also it is maybe not possible for them to deploy the fiber optic connection. But of course, they have a satellite as an option for them to connect to the internet as a backbone. However, it is also involve certain costs, and some countries may not able to afford to pay the cost for this. And of course, if you look into the backhaul, um, yes, you need a power supply to power up the base station. And of course, the base station will be deployed based on the population around the base station, because that's how the telcos make some profit from the deployment. However, you're talking about the government responsibility. Of course, there are certain areas they might deploy these towers not at the what we call the commercial return areas. However, if you look into those region, which is Africa's and certain Arab states where they have quite a big desert over there, it is quite tough for them to have this. And of course, that will affect the last mile communication where our devices is in that sector. Um, so this is where uh, the numbers of the unconnected at those regions are still uh, considered high as compared to uh, the developed country or the affordable country, right? And of course, there are also a study on the characteristic of the world offline population. The people who are the elderly have much lower internet penetration. I think that's common to everybody, and also the individual with low education also often remain unconnected across all the regions. All right, and in 2016, also they found that the 58%, I think this is in the Africa, Arab states, and also in the Asia Pacific, there are 58% of the female are offline as compared to the male 2%. So this is the overall scenario on the world map. However, if you look at recently, I think the pandemic situation has changed this demography, maybe. But if you look into the social media now, I think there's a lot of women showing up on the social media instead of the men, right? So it might be different in the country who are already established with this connectivity, right? But in overall population on this map, so these are the data that we have, the fact that we have to face, and yeah, there are 250 million fewer women online than the men. So these are also one of the concern by the ITU on these issues. So they would like to see about more the gender equality, and of course they would like to see more women has show up or has connected to the internet and benefit from this connectivity. All right. And in 2022, right, I think in response to the report in the 2017, they organized the World Digital's what I call the meetings at the Rwanda. It's one of the African country. And in that meeting, the secretary of the ITU, General Secretary of the ITU, has stressed out that we must step up our work to promote digital technology for the good of all, right? So meaning that these digital technologies has arrived or has able to be achieved or accessed by major population on this map. Uh, and of course, as I said before, there are an issues beside the what I call the beside we wanted to have more connectivity to provide more telecommunication services. Of course, we need to deploy more infrastructure, and that's also will cause the cost. Will be impact to the cost, where uh, the president of the Rwanda has stressed out that we must prioritize public-private partnership to expand affordable digital access and equip vulnerable citizens with the digital literacy skill. So what are the keywords here? The keyword is affordable digital access, right? So these are I think the common concern by everybody, especially for the developing country, and of course those who are talking about the country at the region of the Africas and so on. Uh, this quite a luxury, what I call the luxury facilities for them. But of course, even though it's considered luxury, but it is also a must, or a must of the facility that they need to have. I think it so happened in Malaysia, right? By our minister has introduced what I call the package perpaduan for this broadband, right? And I think this is beside the politics. I think this is also the force by the ITU and by the global requirement, where you wanted to have more people access to the internet with more affordable package and price. Uh, and Yes, even though these are the package that made affordable to those who are B40s, right? But the speed that the set for this connectivity is a 3 megabit per second, which is I think a bit away from the mean of the broadband speed that targeted by the Janela, which is 35 megabit per second. Mean that it's not a minimum, it's a MEAN, mean, right? So yes, of course, if you can afford to have faster connectivity, then you subscribe to the normal package, which is slightly higher than the package perpaduan tadi, right? But they are an option, right? They provide the government provide an option to the people, right? To have kind of connectivity that may be suitable to their needs. Okay, some people they may need faster connectivity, then they can go for the higher data bit rate, but some people they just need connectivity for browsing, for the WhatsApp communication and so on. So maybe they less need the speed of the throughput instead of having a high throughput. Right, and end of 2022, I think we are now in June 2023, so already past half year in 2023. But this is from the report end of 2022. They targeted 96.9% of the Malaysian major populated area are covered by the 4G coverage. Right. So of course there's a lot of debate and response by the public on this. All right. But when I talk to the MCMC, they say that it is in the major populated area. Okay. And yes. So these are the general view about the access and connectivity to the internet. That of course they involve the telecommunication engineering, where this is where I would like to highlight how what are the roles that we can do in bridging the gap through this telecommunication engineering. Okay, so we start with the education. Of course, I think in any transformation that you would like to do, it's always started with the education. If you look into the national education philosophy, right, which is in Malay, pendidikan di Malaysia adalah satu usaha berterusan ke arah lebih memperkembangkan potensi individu secara menyeluruh dan bersepadu untuk mewujudkan insan yang seimbang dan harmonis dari segi intelek, rohani, emosi dan jasmani, right, berdasarkan kepercayaan dan kebutuhan. Right, so at the end of the words, then you can see that it is to contribute to the harmonization to the family wealth and the society wealth and also to the country wealth, right? So end up, whatever we do actually is to contribute to the society and to the nation. And this is, I think, talking about this, I think quite many years ago, there's a lot of model has been wrote about how supposed to be the university or the education system integrate with the society and the environment, right? So of course, in university we are having our core activities is related to the knowledge and also the research. All right. So beside the education and research, of course, we have the organization that govern these two activities. And of course, all this will be end up impact to the society and the environment and also the industry around us, right? So, and of course, we need to engage, right, our activities with the society so that whatever we do, as referring to the national philosophy just now, national education philosophy just now, we are doing all this to be benefit not only the individual, not only a small cell of this society, which is a family, of course, the big society and the nation, right? And that will enhance this engagement. Actually, will enhance the quality and the education material that we have in our university. Right. So this is the common traditional classroom that normally we always have in everywhere, and this is the way has been the classroom has been conducted. I think for many years, right? And of course, there's nothing wrong with it, right? And I think this approach is still relevant, and these are the something that normally material that we provide to in the classroom, right? There is slides, right? So in the slides, then there is theories about the topic that we are going to teach. So for example, this is about antenna. We start with some brief histories about the antennas and how does the radiation mechanism coming out from the structure of the antenna. And so sometimes we need a transformation. All right, so this is the photos in 2017, if I'm not mistaken. So we have a group from amateur radio coming and showing the equipment at our faculty. So I am conducting the class. Conducted the class at that time, and by looking at the setup, then I said to the class, "Okay, let's go." So today we have the class outside the classroom or outside the lecture room, and we go to the field, and from there, since they already set up the antennas. I think this is the HF antenna. So from there, I can show to them what are the antennas all about and how does the dimension of the antenna relate to the wavelength of the frequency of the HF, and how does this antenna can become what you call the air interface between the microwave that travel over the air and be intercepted by the antenna. And I think the student enjoy this kind of learning experience very much. And of course, for the transformation, so beside we have a normal approach in the classroom, uh, uh, it is also good if you can go outside from the classroom. For example, we perform the measurement, all right, on the field. Then the student can really see and observe whatever the design and validate it into the real environment. We conducted a mini project that relate to the telecommunication, and of course we invite the people from industry to deliver some talks to enhance the knowledge to the students in the telecommunication topics. And this is one of these transformation, what you call the agenda that we did in our university. We developed our antenna using the biscuit can from the Jacob can, and we make it as an antenna, because after all, in the first place, we would like to use the aluminium. I think that the most affordable or the most cheaper material beside what we call the copper. However, my student has come with the idea saying that why not we use some biscuit can, which is a reusable material. Then after all, we just need the conductor. Of course, all this aluminum is a conductor. So I said that, yes, why not we explore this idea? And from there, they cut those aluminum plate into certain shape. Of course, we need to calculate. They have the calculation for the dimension according to the frequencies, and connected with the RF connector and cables, and we test the performance of this antenna. All right, and what motivates us to create to design and develop this antenna, right? So I think of course the pandemic or the COVID-19 situation has influenced very much about the digital digital problems to not only to Malaysia but of course across the world. And you can see that there is a situation where the students have to climb the trees, have to stay on on the branches of the trees, right? They have to climb the hills just to get a better coverage, better connectivity, so that they can participate in the online classes and also participate to the test and examination and so on. And this is where we thought that, oh, why not we doing something for the benefit of the of those peoples, right? So then we tried we start thinking that we are using this router, okay, the internet or the Wi-Fi router, which is having a SIM card. And the antenna at the Wi-Fi router is a kind of a omnidirectional antenna. And we think that why not we use this directional antenna for MiFi communication. MiFi is a mobile Wi-Fi system where we distribute the Wi-Fi connectivity using the Wi-Fi frequencies, but however, to connect to the internet, we are connected these wireless router into the 4G LTE base station. Right. So in order to communicate with 4G LTE base station, we just need just a single path of communication. Right. So then if you replace this antenna, the omnidirectional antenna, which is a low gain antenna with a high directivity antenna, and that have a potential to increase the quality of the internet speed, right? So, and of course, you can see that this antenna is not something new. It has been reviewed by a lot of people. You can see also over the YouTube channels. In the YouTube channel, there's a lot of people reviewing this antenna, and the design, they construct this antenna with a certain dimension that already give in the internet. But however, since we are the learning institution, right? So we are not just constructing the antenna, but we do some analysis on this design. Okay, so of course we have to do some tuning. We do this simulation. We simulate this structure and see what are the performance of this structure, and then from there we construct the structure, the antenna structure, and compare this structure to this simulated results, and we found out it is comparable, and we construct at two frequencies, okay, which is 1.8 and 2.6 frequencies. Why 1.8 and 2.6? Because in Malaysia, right? So there are these two frequencies are the most, I mean, the most dominant frequency that are used by the service provider, which is a telco, and this is where we are focusing to have connectivity between the wireless router to the telco base station. So this is the setup that we did in our Chancellor Hall, where we have an event in the Chancellor Hall, and we always get the feedback saying that the internet connectivity, the LTE connectivity in the Chancellor Halls is normally poor. This is because you are inside the building, where the building have these what I call the walls, have a layers of the walls, have a layers of the glasses. Of course, the attenuation from the outside into the hall, they have to go through a few obstacles, which is the layers of these glasses, layers of the walls, and of course the signal will be attenuated. So that's why you can see before we apply our directional antenna, and the connectivity is considered poor, but after we apply our directional antenna, then you can see that the connectivity has become better, right? Which is download speed 24.3 megabit per second. This is another setup that we do near to the Masjid Jami Al-Qasar, which is in the Umbai area. Umbai is one of these village that previously known as the fisherman village. And before we apply this antenna, the distance is about 2.1 kilometer. So before we apply this antenna, the speed is a 4.98 megabit per second, and after we apply this antenna, it's a 28.6 megabit per second. All right, so this is the antenna that we made from the biscuit can, and this is the setup that we perform at the Kampung Sungai Lui, Hulu Langan. If you remember, this Sungai Lui is one of the area with affected by a big flood, I think in last year or last 2 years. and one of the students from that kampung or from that village, and then he tried. He when during the semester break, he bring this equipment, this antenna and those equipments to his village, and he tested. And yes, surprisingly, you can see that from the 11.5 megabit per second and increase up to nearly 50 megabit per second speed, right? So these are the results that shows that bring the excitement feelings to the student, right? So they develop this antenna by their hand, and they can see that the significant impact, the outcome or the results from the handmade antenna to the performance of the internet speed, right? So this shows that so these are the ideas that we try to tell to the student and to tell to the society, that which is the technology is something affordable, something not expensive, right? Not too cheap, but it is not expensive, and something that all people have uh, 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 have a what I call the peluang opportunity, all right, to get the benefit at the lower price, or at the minimum price, or at the minimum cost, right? So that's why sometimes among us we make a joke. So can we call this antenna as a Rahmah solution, or the antenna Rahmah? Right now, the word of the Rahmah is getting popular, uh, and I don't know, maybe this antenna is suitable or not to use that kind of names, right? And yes, this is the most longer distance that we perform the test, which is 5.2 kilometer at Kampung Johong, Jasin. So at the village is quite a remote area in Melaka, in the area of Jasin. And this we are not able to get a good connectivity here before we apply this our antenna. And the speed of internet just 1.45 megabit per second, right? It is below then the package perpaduan, okay, by introduced by the minister. It is very much below, and you cannot do anything. You cannot do anything with this kind of speed. But after we apply our antenna here, then we're able to get 11.18 megabit per second speed, and that's allow us to do a video streaming, to do the video call, and also the online classes using the MS Team. You know, the MS Team is quite heavy compared to the Google Meets and other Zoom application. And yes, of course, that has bring the excitement feeling to the students who are involved, and those students who are watching their friends doing all this. And by having this concept of study, right? So there is one school in Merlimau. Merlimau is one of these area in Melaka. It is considered a suburban area. It is not very much village, but it is a suburban area. So they need to connect two spots in the schools, which is one at the open classroom. That classroom has been designed for the slow learner students, and another area is the hostel, right? So these two areas are they would like to have this internet connectivity because of course, to enhance the digital experience of the student. All the materials now already in the clouds, All right. So if the student has an internet connection, that will be better for the learning process. Um, and however, they in the first place they would like to have a connection with this fiber optic. But of course, for the schools, uh, they are consider what I call the commercial premise as compared to the house, where if the housing rate, normally our subscription at the house is more cheaper as compared to the commercial premises, right? So uh, yes, of course, the cost again has come into the consideration to the school management to decide this. And we propose this. We said that why not you use the router with the SIM card. We call it MiFi. Where the SIM card, I think during the normal school session, the student you can subscribe into the full package, and during the school breaks, the school holidays, then they can tune down to the minimum package so that the school can save money on this. And they accepted this idea, and the PIBG of the schools, and also one of the IEEE society, which is APMTT EMC, has partly sponsored for this project. So I bring the students to the schools to do the site measurement, to do the tuning, and to do the installation, and all the installation process is done by the students. And when they see the results where they can provide uh, uh, the connectivity to the brother and sisters, which is still in the high schools, they feel very, very excited, of course, and they know that they know that whatever they did to that school, that will benefit many, many students, or many future generation that will connected to the internet through these facilities. And as this is the result that we got from the setup, I think from 10.3 megabit per second download is now the performance is 22.36 megabit per second. And with this speed, I think hopefully the student at that school enjoy and get a better benefit from those facilities. Right. So beside using the biscuit can, there is also another design that we use. We utilize what I call this the oil strain. So the oil strain normally we can find dekat kedai goreng pisang tu kan. So we use this as a reflector. So you can see that this is a rabbit antenna, or the kind of monopole antenna that we can see at the wireless router normally. So one of the idea is to have to make this become the parabolic dish antenna, right? So you need the reflector, and uh, one of the uh, one of the shape that can provide this reflection is this oil strain, which is very light and then easy to bring to anywhere. And yes, we tried this, and they put the rabbit antenna or the monopole antenna at the center of this reflector, and we try, and it's worked, right, and able to enhance the speed of the internet connectivity from the poor to the very good results. Right. So this also again to show to the public that which is the technology is not something that difficult or something that to I mean to too much away from the knowledge, which is they also can utilize whatever material that they have around them, all right, for this purpose. And these are the students who are involved in this projects. And in this university, we have a Service Learning Malaysia University for Society, which is SULAM. This program across universities in Malaysia. Where the government or the ministry encourage a student to go outside the university, to go to the society, doing some projects or some assignment in the society. So instead of doing the assignment or projects in the university, go out to the society and solve and help the society by solving the problems. So by using this aspiration, so this is what we did. We bring the student to the societies and knowing the problems and solving the problem through the knowledge and the skills that they learn in the university. And I think this project has get attention by the state government. This is Datuk Sri Sulaiman, the former Chief Minister of Melaka, and of course, when he saw the antenna that made from the biscuit can, he quite interesting and quite impressed with this idea. And this is idea coming from the students. Right, original idea is coming from the students to utilize the biscuit can to become an antenna. And of course, our minister, Datuk Sri Khairuddin, also visited our booth, I think last month. And he's also excited to see how can this biscuit can become the antenna and give a significant improvement to the internet connectivity. Right. And thank you to the IEEE Antenna Propagation, Technology and Technique, and also the EMC Joint Chapter for partly sponsored this project and has awarded us with a Best Volunteer Award last year for this project. Right. So talking about the society, there is the IEEE, which is there's a lot of society in the IEEE. One of the society, beside the APMC, we also have a communication society, which is quite a largest IEEE society in Malaysia, which is also have a program to the societies, which is we have the school series program, where in this school series program, we are sharing the knowledge with the students, with the high school students over the YouTube channel. So you can see that the topic that we share in the YouTube channel is quite a significant topic. For example, about the IoT, about the electromagnetic radiation, about the 5G communication, about the RFID. So I think at certain stage, certain point, I think that is it possible for the student to understand this topic, because talking about the electromagnetic radiation, you talk this topic to the Form 4 or Form 5 schools, they can accept and digest this topic at that level. But if you look back into the robotic technology before this, right? So we learned the robotic during the in the university, right? So the robotic topic programming is being taught teach in the degree level, and after that it goes to the diploma level, and that from the diploma level go to the certificate level. And now the robotic, how to program the robot has also have been taught in the school level. In fact, they have the robotic league, robotic competition at the school levels. So means that we don't underestimate the new generation, because they are exposed to a lot of information over the internet connectivity, and that's where we can see that our new generation now, they are more advanced in terms of knowledge, and in terms of general knowledge about whatever topic that uh, available in the internet, right? So this is where the ITU, the government, MCMC, has the aspiration where we would like to connect more people to the internet, and with that they can get a lot of benefit, a lot of information, and of course they can enhance their life with those information. Right. So this is the YouTube channel uh, by the IEEE ComSoc VTS. So you may subscribe, and of course, they also have sponsored a program. Go to the schools. I think there are many schools that we go and assist the students, the community for this. I think many universities also. I think in UTeM also, we have a RISE center to connect the expertise from universities to the society in the Malacca state, and these are the platforms that are available for the engineers, for the academician, right, to participate and also to contribute to the society. All right, I think with that, I would like to thank you for your attention, and hopefully this talk has give you some ideas about how I personally did bridging the gap between the university and the society over this telecommunication engineering.